So let's continue to our lectures for Linux. The topic which we are studying today is known as RAID. RAID, the full form of RAID is Redundant Array of Independent Disk. Initially, instead of independent, we used to call it Redundant Array of Inexpensive Disk. What is the meaning of this raid and what is the use of this raid is something which we are going to see today, and in the coming lectures we'll be studying about the commands, that how a raid can be implemented by using the Linux commands. What is raid? Raid is basically a group of drives. Initially, the storage was very expensive and it was known as redundant array of inexpensive disk because storage was very expensive and to buy a disk was an expensive part. So RAID came to the picture where we can have large number of disks combined together to store large amount of data, so that if one of the disk fails, we can retrieve the data from another disk. Now it is known as independent disk. There is one disk combined with another disk, combined with another disk, depending upon the level of the RAID. There are different levels of the RAID, and the concept is that suppose if one disk fail, we can retrieve the data with the help of other di- disk. This is what the RAID gives us. There can be different type of RAIDs classified in hardware and software. A hardware type of RAID requires a RAID controller, where there is a hardware device known as a RAID controller which controls the working of all these independent disks, which is easy to manage and which is less expensive, or we can say which is not so expensive. Software RAID required the software intervention. They require the softwares to make the logical volumes and make RAIDs, which is an expensive process, which is not so much preferred. Generally, the hardware RAID controller is used to combine different independent disks and make a RAID. Now, there are different levels of RAID. The different levels of RAID gives different performance and different capacity of fault tolerance. There may be a case where we require huge performance, then we have to compromise with fault tolerance, or there may be a case where fault tolerance is more important and performance is not so important. So we can choose the level depending upon the need. There are different levels: 0, 1, 5, 6, and RAID level 10 also. These four levels 0, 1, 5, 6 are depends upon the working of these levels, that how the disks are organized and how fault tolerance can be achieved in these levels. For example, if we talk about RAID 0, the RAID 0 works on the principles of striping. Over here, fault tolerance is not there. We cannot have any fault tolerance. If our disk fails, then the data is lost. If there is one hard disk and another hard disk, and we are storing, for example, Linux in these two hard disks, it will works on the principle of striping. L will go into the first hard disk and then I will go in the second, then N will go in this and U will go over here and X will go over here. The data is striped and it is stored in different disks, and this gives us the ability to improve the performance. Reading writing speed improves, but fault tolerance is not achieved. If a disk fails, data is lost. If a disk fails, data is lost. So that is RAID 0. Then there is RAID 1. In RAID 1, the concept is used of mirroring. Instead of striping, it uses the concept of mirroring. What does this mirroring means? If there are two hard disks, the same data is written in both the disks. The mirror copy is there. If there is a fault in one of the disks, the data can be retrieved from another disk. This is the concept of RAID 1, where if one data falls, if one disk falls, we can have the data from the another disk. Then there is a concept of RAID 5. RAID 0, RAID 1, RAID 5. RAID 5 has a different concept which is known as a parity concept. Over here, parity bits are stored in each drive which can be used to retrieve the data. Even if one of the drive fails, because of the parity information which is stored in all the drives, the data can be rebuilt. For example, if we are having 4 disks of 1 TB each, these 4 disks will be divided in such a way that 256, 1 TB was the size, 256 bytes are reserved for the parity in each of the drives and rest for the data. Suppose if this disk fails, we can retrieve the data by using the parity information which is stored in other 3 drives, and this disk can be rebuilt again by putting another drive into the place. So the data can be retrieved in this. This is the concept of RAID 5. Lastly, let's see what is RAID 6. RAID 6 uses the concept of distributed parity. It uses double parity basically. It uses the concept of double parity. Instead of one parity information, it uses double parity information, and minimum 4 drives are required to build a RAID 6. Minimum 4 drives are required, remember, to build a RAID 6, out of which 2 drives will always be reserved to storing the data. In RAID 5, if at a time 2 disk fails, then we cannot retrieve the information. But in concepts of RAID 6, even if 2 disk fails, we can retrieve the information because 2 drives are kept separately for storing the parity information. Even if 2 drives fails, then the information can be retrieved by using the parity information which is saved in 2 drives separately kept for the parity. So this is what a brief overview of what is RAID 0, RAID 1, RAID 5, and RAID 6. There is one concept known as RAID 10 also. We will not speak much about it. RAID 10 is a combination of RAID 1 and RAID 0. Similarly, we have RAID 01, which is a combination of RAID 0 and 1. So this is all about RAID. Now in the coming video, we'll be focusing on how we can implement RAID in Linux. Thank you.